Hey, welcome to this project of today, and today we are going to present VRRP HSB configuration. So where we are going to implement a hot standby backup, where in case AC1 goes down, AC2 should be able to take over the service communication. So this is how our topology will look like. It's just look like the previous topology for the previous practical, but in this one we are going to implement what is called VRRP. So what is a VRRP? So VRRP is a fault tolerant protocol that improves network reliability. So in case the master, that is AC1 here, goes down, AC2 should take over. AC2 here should take over the role of the master to ensure continuous service communication in the network. Also, this creates what is called reliability, so that in case AC1 goes down, the STAs should be able to work in a normal as if AC1 was still active. So let's look at our requirements. So as the number of STAs on the enterprise internet keeps increasing, to ensure the stability of wireless services, you, a network engineer, decide to purchase a new AC to form a HSB group with the existing AC and configure the HSB group to work with VRRP to implement AC HSB and improve the reliability of wireless services. So data plan look like this one. So management VLAN is VLAN 10, the service VLAN is VLAN 11. Switch 3 is going to function as the DHCP server. Then the IP address pool for the APs is 10.0.10.0/24. IP address for STS is 10.0.11.0/24. AC source interface address is 10.0.100.254, and it's also going to act as the VRRP virtual IP group as we've been using depart, and also the security is the same, SSID the same, VRRP the same name. Then you see here we have got VRRP group. We are going to VRRP group ID of 1. Virtual IP, as we just said, is 10.0.11.100.254. IP address and the port number of HSB channel for AC1 is 10.0.100.1, and the port number is 10,241. IP address and port number for HSB of AC2 is 10.0.100.2, and the port number is 10,241. Actually, we are going to see the port number range from 10,240 to 47,000 with some digits. So this is the HSB is actually going to be created to ensure synchronization between the master and the backup ACs. So this is our topology. So as our previous projects, we've been using the same topology. So configuring the layer 2 parameters and also layer 3 parameters is the same with the one we've been configured. So in this one, I set the configuration for the layer 2 and the layer 3. So as even if you display, you can display and see the configuration that on that device. So the VLAN had been created, VLAN 10, 11, and 100. Also, you can see the interfaces. VLAN if 10, interface VLAN if 10. I've been given IP address. Also, this time we've configured what is called a description. That is AP1. So it's just the same description. You just create on that interface. So after you create interface VLAN if 10, you give it a description. After the description is when you give it the IP address, as I've just done here. You see, as it is done, you give it the description, then you give it the name. Also, the interface has been configured to allow the VLANs which are required to pass. So that's for switch 2. Then you go and check for AC1. Check AC1. See what has been configured. The VLAN batch 100 has been created, and the interface gig 1 has been created to allow pass VLAN 100, and also we've configured layer 3 parameters, that is VLAN if 100 with the IP address of 10.0.100.1/24. It's the same as with C2. So from there is where we start our configuration. The first thing we are going to do, we're going to configure a static route to tell the AC the network where the management and VLANs belong. So we are going to configure a route to switch 1 here to tell the AC the network where the APs belong. So let's just jump into our today's task. So to that, configure IP route static. Then the network will be 10.0.10.0 mask of 24. Then our next stop will be 10.0.100.3, though that's the gateway on the switch 1. After you configure that, you also come on AC2 here, you do the same. So configure IP route static. Then the network is 10.0.10.0 mask of 24. Our next stop is 10.0.100.3. So meaning that when you are on that AC, you should be able to ping the network of the ACs of the AP, I mean 10.1. Yeah, there's connectivity. So after that, what we are going to do is to implement the DHCP server on the switch there. So on the switch, we create a DHCP, enable DHCP enable, and it is going to be created on a pool base. So we say IP pool, then the name we say AP. On that, we create the gateway list. So it will be 10.0.10.1, the network of 10.0.10.0 mask of 24. Then we configure DHCP option 43 to tell the IP address, to tell the APs the IP address of the AC. So means that when APs send packets to the switch to request for the address of the AC, should get it from the DHCP option 43. So option 43, sub option 3, ASCII. Then we are going to give it the IP address of that virtual IP.0.100.254. To that, I create a IP pool for the STAs. So say service. So then the gateway is your 10.0.11.1. Then the network of our network will be 10.0.11.0 mask of 24. Then you configure the DNS list of 10.0.11.1 and also enable it on the interface VLAN if 10. You enable the DHCP select global. Also VLAN if 11, select global, then you save your configurations. After that, we are going straight away to WLAN service configuration. So under the WLAN view, create the AP group. AP group name, give it to the name that was suggested by the work plan. Then you quit and create a regulatory domain. Regulatory domain name, you're going to give it VRRP. And country code, set it to CN, China. Quit and you bind that regulatory domain into the AP group. Bind that regulatory domain into the AP group. Say yes. Then, before you come here and copy the MAC address of these APs so that you can be able to import them offline. This is the MAC address. Copy. Also come, but make sure they're in the group of 4. The group of 4. So this one. Come to AP2. Copy its MAC address. Group them into a group of 4. After that, you start your devices. Start your devices, then you continue with the configuration for the WLAN. So you create an AP authentication mode is MAC authentication, then AP MAC, give it the MAC address. Come and copy the first MAC address here. Then you give it the AP name. This was AP1, and add it to the AP group. Was depart 1. Depart, say yes. Then create AP group, AP ID2, ID1. Then AP MAC, then you come and copy the MAC address. So the AP, give it a name of AP2. After that, add it to the AP group. AP group. Yes. Great. For now, we are still not going to configure the CAPWAP source. So even if you display the AP all, you'll not be able to see the APs brought online. So being normal in a more normal state. So the reason why we have not configured that, we want to configure first of all the VRRP and the HSBs is when we configure now the CAPWAP source and see the APs coming online, and also see the radios and the STAs being able to acquire IP address from the DHCP server. So still on the WLAN view, and now you create the security profile name as you just used for group, then a security WPA, WPA2, PSK, passphrase, then you give it that name. Then you give it the encryption standard. Let's check the encryption standard that we have. We have got 3 encryption standards, either the American and Advanced Encryption Standard, Advanced Encryption Standard, TKIP, or TKIP. So for our case, the practical told us to use the Advanced Encryption Standard. So that's the Advanced Encryption Standard. After that, you quit and you create the SSID. So SSID profile name, use the same name. And SSID, we're going to say give it HSB. Quit and you create the VRRP profile name. Give it the same name. Then you bind the forward or to be direct forward. Also the service VLAN to be VLAN ID 11, and security, we bind the security depart. Also we bind the SSID to that VRRP. After that, I quit and enter the AP group view. AP group name, we said was that. Then after that, we bind the VRRP. We bind the VRRP to the AP group. So WLAN 1 radio all. When you say radio all, means that we configure both radio 0 and radio 1. So both the channel 1 and channel 149 should be able to come up. We said channel 1, channel 6, and channel 11 are for 2.4 gigahertz, and channel 149, channel 153, channel 157, those are for channel 161 and channel 164. Those are for the 5G frequency. After that, a quit. Then the thing we're going to do is now to create the VRRP. So first of all, we create a recovery delay. So VRRP. Let's create the VRRP recovery delay to, let's say, 60 seconds. After that, I enter interface VLAN if 100. If 100. So you are told to set the preemption delay to 100. The preemption priority, the priority is going to be set to 120. So first of all, let's say VRRID we said was 1, then the virtual IP was 10.0. 100.254. For that, we're going to create the priority, VRRP priority. As you all know, the VRRP priority for the wide devices is 100. So for this case, the higher the priority, the higher the preference. So when we set a priority of 120 for this AC1, it's going to act as the master. Then AC2 will take the default priority of 100. So VRRP RID 1 priority of 120. Then we also set the preemption delay of 60 seconds. So VRRP VRRID of 1. Then preemption mode timer, we set delay to 60. Okay, After that, we enable admin VRRP VRRD 1 and you quit. After that, after configuring the VRRP, what we are going to do is now to configure the HSB link that is going to enable, that is the hot standby, to enable for services on switch on AC to be synchronized on switch on AC2 seamlessly. So we're going to create the HSB service, HSB service 0. The HSB service 0, I want to create service IP port local IP address we said was 10.0.100.1. Then the peer IP port will be for the AC2, that is 10.0.100.2, and also the local port will be 10.241, or let's see as I said there, and see the range for the local port. So you see it's an integer ranging from local port is an integer ranging from 10,240 to 49,157. So local IP port of 10.241 as you were told in the record. Then the peer port will be also 10.241. After that, I'm going to configure service keep up alive, then retransmit detection, retransmit 3 seconds, then interval is going to be they're going to create interval of 6, and we quit. After that, what you're going to do, you're going to create a HSB group. Then after you create the HSB group, you're going to bind now the service 0, HSB service 0, and also we're going to bind the VRRP into that HSB group. So HSB group 0, to that we bind service 0. Also we also bind the VRRP VRID 1 VLAN if interface VLAN if 100. Also we are going to bind the NAC into the VRRP group. So we quit and also enter service HSB service type is a access user, then HSB group 0. Also we bind that one, we bind the NAC. Now we bind the WLAN service. So now it will be HSB service type to be AP and HSB group 0. Yes, so that is it. After that, what we are going to do is now to save that configuration. And also come to this other AC here. You're going to configure also the same things. So what you're going to do, enter the WLAN view. The WLAN view, we're going to let's create the HSB. Sorry, before we proceed, come to this first AC here, and we're going to enable HSB on the AC on the HSB group. So HSB group 0. Now enable HSB enable. So after I use that command, the HSB command should be able to take effect. Wait and we save the configurations. Say yes. So that's is it. Guys, you also go to the other AC and we do the same. We're going to create the recovery, so create the VRRP recovery to 60. After that, I will create the VRRP, enter the interface VLAN and give it interface VLAN 100. Then VRRP VRID virtual IP VRID of 1, virtual IP is 10.0.100.254. Then we said this one is going to use the default priority, so it's a priority of 100, so there's no need to configure that default priority because definitely the default priority is 100. So the thing we are going to do now is configure preemption VRID preemption mode, ID of 1 preemption mode, timer delay we set to 60 seconds. Then admin VRRP VRRD 1 quit, and for that you enter the HSB, you create the HSB service, HSB service 0. The HSB service you create the local service IP port, local IP of 10. This one now is going to be, because we are on AC2, the local IP will be its IP address .100.2 service peer IP will be 10.0.100.1, that is for AC1. Then the local port will be 10.241. Then the peer IP port will be 10,241. After that, you create the service, the keep alive detection, detect and retransmission time is set to 3 seconds and the interval of 6. And you quit. After that, you create the HSB group that is going to give us for the used for the HSB link, HSB group of 0. In the HSB group, you're going to bind the HSB service and also you're going to bind the VRRP we just created. So bind HSB service 0, then track VRRD 1 interface VLAN if 100. Then you quit. After that, you're going to bind the service type to that is the NAC service and also the WLAN service into in the HSB group. So HSB service type of access user, then HSB group 0. Also we bind the HSB service type for the WLAN, so HSB service type AP and HSB group is 0. After that, what we are going to do, we are going to enter into the HSB group and we enable the HSB function. So HSB group 0, then you enable HSB in that view, and you quit. Save configurations. After that, guys, now we can configure now the source CAPWAP source IP address. So on AC1 now we can configure the CAPWAP source and see if now the circles will be able to come up. So in CAPWAP you can either configure in interface based or in IP based. So let's see CAPWAP source. So you see here it can either be in interface based, so you can say CAPWAP source interface 100 or CAPWAP source interface IP address, because in this case we are not going to use VLAN if 100 as our CAPWAP source interface, but we are going to use the virtual IP as our CAPWAP source IP address. So for this case we will not use the interface based, we are going to use the IP based. So CAPWAP source IP address, now we're going to give it IP address for the virtual IP, is 0.100.254. After that, when we give it time, like we said, it's supposed to be 75 seconds as it's collecting the packet. So you've seen our first circle has been brought up. See the circle, and both the circles are now up. So we are going to bring our stations, and we're going to bring our stations and try to connect them, see if they will obtain IP address. So we start let's start them at once. After we start them, we are going to now give them see if they are going to obtain IP address of. Then we are going to check our HSB if it's active. Let's give it. Sorry. The password is refusing. Why? Since I forgot the password I just configured on those devices. That's so funny. That's so funny. Why is it that I forgot that? Password that I configured in that security. Let me check if so it was okay. I see the password I configured was okay. Let's connect it. I didn't use the password that they gave. So after that, now let's see if it was obtained an IP address. Yeah, obtain an IP address. Also, let's connect this other guy. Same to this other guys also. Let's connect them to and let them obtain IP address. So okay, so now what we are going to do, try and display and see our HSB. We're going to verify our HSB. So come to this VRRP. Sorry. Let's first display. So we see our AP is in an app state. It has obtained an IP address. And also see, let's see here. Now we come here also, we're going to configure the WLAN. So say WLAN. The WLAN will create an AP group. AP group, you're going, this is AP group name, is give it to that one. And you quit and create the regulatory domain name of VRRP. Country code CN. So that we bind the regulatory domain into the AP group. And regulatory domain VRRP. Say yes. Wait. And come and add the MAC addresses. So we copy MAC address, add to the AP authentication mode, MAC authentication, then AP MAC, give it the MAC address, then AP name, this is AP1. That add the AP group, that one, the one that was given, so yes. Also AP ID 1 and AP MAC, you copy the MAC address. To copy that MAC address, you add it to that copy. Then AP name, said this one going to be AP2, and add it, bind it to the group, bind it to the AP group. Say yes. Display. Okay, quit. After that, you quit, and create the CAPWAP source IP address, not source interface, CAPWAP source IP address of 10.0.100.254. Let's display. State, so let's just give it time. Let's give it time. Display the VRRP and see So when we display the VRRP, we are on virtual router 1. So the state here is the master. So means that AC1 is acting as the master. Then the virtual IP for AC1 is 10.0.100.254. The master IP is 10.0.100.1. Then the priority run is to 120. The priority config is 120. The master priority is 110. The preemption delay preemption was set, so the preemption time was 10 seconds. Then when you come here, you can see the virtual MAC TTL, yes, and also the config type we set it to admin VRRP. So that's it on that AC1. Now come to AC2. It was acting as our backup, so display VRRP. Display VRRP. So in this other state is backup, so AC2 is acting as the backup. The virtual IP is 10.0.100.254. The master IP is 10.0.10.1. So you see it's recognized as the master IP. Then the priority is 100. So as we said, the default priority is 100. So the priority config is 100. Then the master priority is telling us the master priority is 120. The higher the priority, the higher the preference. So the one with the higher priority will act as the master, and the one with the lower priority will act as the backup. So that's it. Config type was admin VRRP. After that, we display the service, and we see. Let's display HSB service 0 and see. So HSB service 0, the local IP, we can see here the local IP address is 10.0.100.1. The peer IP is sent to 10.0.100.2. The source port is 10,241. Destination port is 10,241. Keep alive times is 3. We set it to 3 seconds. Then keep alive interval was 6. So service state is connected. In the service bus modules, you can see modules. Also, you come on this side, so you display HSB service 0. You'll be able to see the same thing. Now this side, now the local IP is .2, and then the peer IP is .1, and it is in the HSB group, and display HSB group 0. So in the HSB group 0, the group ID was 1. Then the source VRRP interface was VLAN 100, and the group status is master. Group status is master, and the group VRRP status is master. Group status is active, and group backup process is real time. Then the device, the peer group device name is AC 2005. Then the group backup modules that we configure was access user, that is for the NAC, and the AP, that is for the WLAN service. And you come to AC display AC2 here, display HSB group 0. HSB group 0, the VRRP interface VLAN 100. The state VRRP group status is backup, and backup process is inactive and it's in real time, and the group backup modules is AP and the access user. So as we have seen, guys, the our HSB links are active, so means that when AC1 here goes down, AC2 will be able to take over the role of AC1. So enter into the WLAN view. In the WLAN view, we are going to create this the WLAN parameters. I'm going to give it depart. And the security we are going to give it security of WPA2. PSK passphrase, that is Huawei 123 American advanced encryption standard. Quit, and you put the SSID name, give it the same name. After that, thing we are going to do is to give it the SSID of HSB. Wait, now we create the VRRP. Create the VRRP profile, give it the same name. So then you bind what should forward direct, then the service VLAN ID of 11, then the security was the one we set there, and SSID. Then you quit and you enter the group view. So AP group name was that one there. After that, you bind the VRRP into that group. VRRP profile. VLAN 1. Then we bind all the radius. Quit, and you reset the AP reset APs are still in the idle state, but everything is okay. Sometimes you find that maybe the link here is not allowing the service package to pass. So gig 1 and capture packets on gig 1 here. So capture packet on gig 1. So you see gig 3 and gig 4 are showing signs of being down. Let's also see this other side. Gig 3 and 4. Okay, they are up. So we want to capture packet on gig 1. We want to capture packet on gig 1 and see what's going on in that gig 1 and see how the VRRP is able to exchange the TCP packets. So let's see it and see how the TCP packets are being exchanged. Then the negotiation. Yes, the synchronization and the acknowledgement. Okay, you can see the CAPWAP announcement. So you can see the CAPWAP announcement. can also see the TCP. You can see here, see this TCP, TCP keep alive. So that's what's happening, guys, on the how the packets are being exchanged in that link, the upper link. See the VRRP announcement. We have got VRRP announcement. Sorry for that interruption. Let's get back to and see how the exchange is taking place. You can see here, we have got the acknowledge the sequence number, acknowledgement, the window, the length, and the VRRP announcement. You see how the VRRP negotiation is taking place. We have got the AC1 here is sending a TCP. TCP keep alive. We have got the CAPWAP also. You see the CAPWAP negotiation. I've got the gratuitous ARPO for this one. To check if there is any IP conflict. So this is the negotiations that are taking place. So we have got the protocols. You have got the CAPWAP, the TCP, VRRP, and so on and so on. And as you can see here, so that is what's going on that interface. We are asked who is 10.0.2, tell 10.0.1, something of that. Something very interesting. The good thing with this thing is you see as they are exchanging packets in real time now. The sequence number, the way the sequence number is changing. See, from the start, sequence number is 73, acknowledgement is that one, and it's increasing in that sequence. Yes. Now let's go back to our IP here. So our IP has gone down. So what you do is you so our devices are still restarting. As you see there, so we stop them. Let's try and stop them and start them again. So maybe because our CPU has been overwhelmed, it has been working throughout. So let's try and stop the devices and see and start them again and see if now it will be able to work. But guys, the main thing that we were trying to implement was the VRRP and the HSB, and you've seen both are active and they have been connected. The master and the backup AC has been implemented, and they are the AC1 is the master, AC2 is the backup, and they are ensuring reliability in the service provision. see the announcement here, how the VRRP announcement are being made. So this is just to check if the VRRP and the HSB links are active, and as I can see here, where the VRRP announcement is made and this receiving VRRP packets. Well, it is idle now, so you see our network is not stable, as you see right here, meaning that our network keeps on coming up and going down. So that when the network is not stable, the packets from the AP will not be able to pass to the upper ACs. So with that, guys, until we give it time, shut it down. We shut down our PC so that the processor can cool down. But the main thing is that you saw what I implemented before the power went down. You saw actually the AC coming online and also the AC coming normal. And once both the links are active and